Okay, hello, I'm Malcolm, a senior software engineer at StackState, and today I want to introduce using OpenTelemetry and the StackState platform. In front of me, we have a scenario that has been set up for this introduction and demo. It's basically a real-world example of IoT devices taking various information about the environments, for example, light, temperature, and humidity, and pushing this into our architecture. Now, if we look at the very first part, we have the IoT devices. These are responsible for capturing these sensor values. These sensor values is then pushed into a API gateway, which is this first entry point here. And essentially this information is then consumed by this controller Lambda function. Now the job of this controller Lambda function is to determine what are these sensor types. And based on these sensor types, they are pushed into their own unique queues. So we have three unique queues. The one is temperature, the other one's light, and the very last one is humidity. Now from these queues, the information is then consumed by their own respective lambdas. The job of these lambdas is basically a few things. The first will be to determine if there's any alerts that should be generated from these sensor values. If any alerts should be generated, this will be essentially be pushed into the notification queue, which we'll get to in a second. And the last part of these lambdas is to write these values into a RDS database. Now we have one unique case where the temperature lambda has to go out to an external API and retrieve weather conditions. Now, based on these weather conditions, the temperature lambda will formulate new formulas and determine new alerts. And yes, but it may vary, depends on where the IoT device is actually located. Now, the last part in this architecture is the notifications part. So we have an entry queue there. This queue is then consumed by the Lambda function, and a notification Lambda function then sends this information into a SNES. So the entire job of this part is to send out alerts to clients based on if temperatures are incorrect, if lux is incorrect, and so forth and so forth. These alerts are basically created by the clients themselves, and based on those, the emails will be sent out to respective locations. Now, looking at the architecture as a full again, let's introduce a few errors based on this scenario. Now, let's take this very first part. The controller is basically responsible to talk to these queues, and these queues has certain identifiers. So this is how the controller knows to communicate with the correct queues. Now, while the developer was busy doing some updates, he or she accidentally added a extra identifier into the light queue, meaning that if the controller now attempts to talk to these queues, it will essentially try and communicate with the incorrect light queue and not the one that's created here, which means that we should somehow see some communication from the controller side to this incorrect queue that it's attempting to push data into. And then the second problem that's introduced into this scenario is the weather conditions that this temperature lambda is attempting to talk to. So now let's say the API key that was used for this lambda to communicate with this external API was invalidated or changed during testing, and the developer forgot to change this back, meaning that the communication that this lambda is attempting to this API will now be restricted, and it will definitely not generate the correct values based on the formulas, as it does not have any weather conditions. Now let's move over to StackState and see this architecture as topology. So now in front of us, we can see the same architecture. So to quickly have a run through, we have the entry API gateway at the very top, which then goes down to this controller. And we can see the controller has missing links. So it has no relations between the lux, humidity, and temperature, which this is where OpenTelemetry will come into play. It's as soon as we start generating traces in this architecture, we'll see actual communication between these services. And then similar to the notification service, we can see nothing is communicating with this service. Let's also, I'm also going to refer to those errors we mentioned. Those errors are actually currently introduced into this architecture, but we do not see any alerts. We do not see any alerts based from the temperature side of things. And we also do not see any alerts that the controller is attempting to communicate with the wrong service. Now, this is where OpenTelemetry comes into play with StackState. As soon as we start generating these traces, we will actually start seeing these hidden errors on these within these lambdas. It's code related within these lambdas, so we can start seeing these code related issues popping up with these communications that the lambdas are attempting. So let's go start generating data in this architecture. So we have this temporary function that I created just to generate some central data, some fake IoT central data into this architecture. So let's call this function a few times just to start generating some data and to actually show us some relations between components. Generating a few of them just to make sure we have some data flowing through the system. Now let's move back. So if we give this a few seconds, there we go. We can start seeing some new relations. We can actually see some communication between services. So if we go down this API gateway again, we can see we have the actual controller. And this controller is now actually communicating with temperature and with humidity. Oh, and there we have some errors already propagating through the system. Some of them might take a minute, some of them takes a few seconds, like we just saw. So we can see this controller communicating with temperature and humidity, which is correct. But we can see at the very top it's communicating with a weird service. It is not communicating with the lux service at the very bottom, as we're expecting with humidity and temperature, but it's communicating with this strange service at the very top. So let's first fix this service before moving on to the, well, actually we can wait for for the half state to first propagate. So let's look at the second problem at the moment. We can see that the temperature lambda is communicating with this HTTP endpoint, but it is basically showing us that there is a problem occurring. Now, for security reasons, we do remove, you have the option to remove query parameters and so forth, which is enabled on this. So we cannot see the API key at the moment for this weather API. So we can go investigate what might be the problems related to the to this architecture. So we can still wait maybe a few seconds for this to propagate and actually show error. But for now, this should show in a bit. But we can go start solving these problems, start debugging them while this is propagating. So if we investigate this, basically this component, and we say show all properties, let's see if we can see what is incorrect here. So we can see we have the queue name, we have lux, the count ID, region. Oh, and we have this weird hello world at the very end, which is very strange. And that seems to be incorrect. We can take one of the other ones that the controller is successfully communicating with, and we can compare that. And yes, we can see the very end, it ends with the region, but the other one ends with this weird hello world functionality. So let's take a note about that. And when we go to the component, we can basically debug that. Now with the HTTP one, we can basically say, okay, cool, there is some restricted access to this HTTP one at the moment, which is pretty strange. And we can maybe go and just investigate that Lambda to see, okay, cool, what is maybe running. So if I go to the controller Lambda, which is the one that does the communication with those queues, and we just investigate the queue names, there we go. We can see this one looks strange. It looks different to these ones. So let's go and change the queue name to the correct queue name and just save that. There we go. And now let's head over to the temperature Lambda, which is this one. And let's see if we can find what's wrong with the API. There we go. Weather API basically testing incorrect key. That's interesting. So the developer never changed it to actually use the correct key again. So let's move over to the weather API. Let's just generate a new key and let's copy this key at the very top. There we go. Let's go back to this weather API. We add in this new key. Let's verify this key looks correct. Save this. And there we go. We have those two problems fixed now. If we go back to StackState, we can see, okay, cool, let's just investigate. We can see, okay, basically those are the two current problems that is occurring. Okay. Now let's generate some more sensor data And let's see if those problems basically get solved. So let's generate some more central. Let's go see what was that about. Oh, we can already see things are starting to get clearer. Generate some more data. Interesting. We can see things are starting to clear up. Let's give it a second for the trace data to actually start moving through the system. And there we go. We can start seeing some things appear. Now, we still have this trace at the very top. Traces do take 15 minutes to expire. So after this 15 minutes, because it's not communicating with the service anymore, oh, you can see that the health state also changed of this component. We're just waiting for it to also display on the topology, which is correct. Sometimes the health state takes a while to propagate when it's the first time the component appears, especially if the component didn't exist before, like this one. But if we look down at the controller again, we can basically see that it has 3 lines of communication now. It's communicating with temperature, lux, and humidity, which is correct. And then if we look at the temperature one, we can see that this is also green. So if we give this a bit, we will basically have a healthy state running through the system, and after 15 minutes, this one should disappear. So that is how OpenTelemetry basically brings in this oversight and this insight into communication between lambdas and various services, where initially this was unseen because we didn't actually inspect what the lambda is internally doing. Okay, we also have this extra perspective. Oh, there we go. We have green on both of these. So basically this is not producing error anymore. The lambda is not trying to communicate with this. So the error state of this basically went away. And after 15 minutes, this component will also be removed. Sorry, this one. This component will also be removed as communication is not happening between these components anymore. And then the HTTP one is successful. So we also have extra perspectives. So if we go to the traces perspective, you can basically see all those traces that was pushed through the system now while we were running our tests. So if we, for example, just click on one of these, you can see the weather API, for example, or the queue that it was communicating with. Or if we open a few more, you might get various information in these. So these are all queue communications. This is the SNS communication, for example. So all of these traces perspectives is basically different traces that was sent through the system at that time. And you can also click on one of these and get a bit more information. So we can actually, for example, let's take the SQSQ one. We can show all properties and you get a lot more information. So you have, for example, the identifiers that was used, the services that was used in AWS, what type of library was used, like the version of the library, what was the status of that, and so forth. You have a lot of information about these traces. And then we have this last little tab at the top called the metrics perspectives. And if we just go back to live on these, we can just wait for these to load a bit. And there we go. You can basically see various information about all these services that was captured. So we can see the actual response times, and you see the API running there, and there's the queue one. And then you can see basically errors that happen. So you can see that the HTTP GET request, that is quite a few errors running on it there. And yeah, so forth. We actually have all the error counts and all the various metrics on this single page, all based on this previous topology that we saw. And yes, that is OpenTelemetry, and how OpenTelemetry basically brings in this value add on top of the topology.